Well, I forgot to hit the record button, so just recorded the whole video. This is the end result. Um, so let's start over. I did a great job too, by the way. It was a fantastic explanation. Fantastic explanation. All right, so let's. Sorry, though. No reason to get upset. Okay. Central ink. So again, the reason I don't want to zoom in because I want to be able to see all this at once. So you guys are going to have to look at your handout, your note handout, if you can't see this, and probably you're going to have to. Okay, so central angle we defined as an angle with vertex at the center. Okay, so this was circle C. Okay, so C is at the center. Okay, so remember we defined a circle as an infinite amount of points. An infinite amount of points that are all those points are a fixed distance away from the center. So that is the circle. Okay, and then our angle is any angle that has a vertices at the center. So for example, angle ACE. Okay, angle ACE is a central angle. Angle ECF is a central angle. Okay, angle ECF is a central angle. Okay, C is the center. We also have angle DCF. Okay, and we can mix it up too. We can say angle DCE. Okay, that's going to be a straight angle. Okay, we could do angle FCA. Okay, there's a lot of different angles we can do. But notice what we have in common is the middle letter is C, because C is the vertex of every central angle, because C is the center of the circle, and a central angle is an angle where the vertex is the center of the circle. Okay. All right. Arcs. So let's define our arcs. Are just going to be part of the circle. So again, the circle is the outside. Okay, it's the infinite set of points that are a fixed distance away from the center. So again, we set our center with C. So our circle consists of all the points that are a fixed distance away from that center, the same distance, equidistant away from the center. Okay. An arc is simply part of the circle. Okay, an arc is simply part of a circle. So if we just take a part of our whole circle, for example, DF, okay, that's going to be called an arc. If that arc is more than half of the circle, for example, more than half, then it's going to be a major arc. If that arc is half the circle, that's going to be a semicircle. And if that arc is less than half, for example, DF, then it's going to be a minor arc. So a minor arc is part of the circle, it's shorter than half the circle. Okay, the major arc is longer than and the semicircle is half, exactly, half the circle. Okay. So DF, the arc we have highlighted here, is less than half of the circle. It's shorter than half the circle. Okay, so it's going to be a minor arc. So we use the two endpoints to define it. So the two endpoints are D and F, so we want to put DF. Okay, and a little kind of half circle, kind of arc looking line on it. All right, instead of a segment line or ray, it's an arc. So we put a little kind of arc symbol on top. Okay, but there are two ways to connect D and F. Here we have picked the shorter way, so less than half the circle. The other way to connect D and F is to use the longer part of the circle, so longer than half the circle. go around by going around the other way. So if we go around the other way, okay, the red line here, that is an arc. It's part of the circle. It's a major arc because it's more than half the circle. Okay. But the way we're going to distinguish that from the minor arc is we're going to use a third point. So if you just write DF connecting the 2 points, we're going to assume it's the shortest path on the circle to each other. That arc is the shorter path. If we want a major arc, though, we have to specify a third point to distinguish it from the minor arc. So we want to use the 2 endpoints, D and F, but we want a third point on the circle. So in this case, either A, E, or B to help define our major arc. So we're going to call it D. Any of them will work, A, E, or B. Let's use A. So D, A, F. Okay, and we put the arc symbol on top. So arc DAF is the major arc. Arc DF, written this way, is the minor arc. Minor arc, the shortest distance between them. Major arc, the longer path along the circle. So just to pick another example here, how about A, let's do it in blue though. AF. Okay, the shortest distance from A to F is this path along the circle. Okay, and we're going to call that the minor arc because it's less than half of the circle. So AF. Okay, we can then do the longer path along the circle. Okay, which is going to be this one. That's more than half the circle. Okay, so if it's more than half the circle, it's a major arc, and we need a third point. The only point we have here is D, so we have to use D. So arc ADF. Okay, ADF is a major arc, so we use the third point. Okay, and we can do one more example. AD, for example. So AD would be our minor arc. It's less than half the circle, so we say AD. Okay. The major arc is the longer path around. Since it's the longer path, it's greater than half the circle. It's greater than 180, really, because half a circle is going to be 180 degrees. We have to use one of the other points, E, B, or F. Let's just use B. So arc A, B, D. A, B, D. Let me put the line over. So that would be the minor arc connecting A and D on the circle. This would be the major arc connecting A and D on the circle. Could call it A, E, D, or A, FD. Could call it DFA, DBA, DEA as well. Arc for all those. Okay. Then the last one we have on here is the semicircle, which is half the circle. So we notice again, just like any 2 points on a circle, there's 2 paths to connect them. So we could connect them this way along the red path, okay, or we could connect them the other way along the blue path. And again, since there are 2 different ways to connect them, if we just wrote ED, okay, we don't know which way we're taking it. If you just say ED, are we going this way or the other way? We don't know. So we don't want to use ED. Okay, we want to use a 3 points just like we did for the major arc. So in this case, the only part on the blue side is going to be A. So E, A, D is one semicircle. Okay, and the other one is going to be E, B, D. Or you can name it EFD or DFE or DBE. Okay. So the central angle is going to be the angles where the vertex is the center of the circle, in this case C. So all our vertexes and our angles are C. Okay. Then we have arcs, which are parts of the circle. So the circle are the infinite set of points that go around the central point. They're all a fixed distance. All those points are a fixed distance away from the center, meaning they're all the same distance away from the center, or they're all equidistant from the center. The minor arcs are going to be shorter than half of the circle. The major arcs are longer than half the circle, and the semicircles are exactly half of the circle. To name the arcs, if it's less than half, the shorter distance, because there's two paths between any 2 points. The shorter of those two paths is going to be less than half the circle, unless it's a semicircle. It's going to be less than half the circle. So if it's less than half the circle, you just use those two endpoints of that path, like we said with A and D. Okay. And then the major arc is going to be the longer path. A to D goes longer than half of it. Okay, and then if you do that, you need to use a third point, E, B, or F. So arc A, B, D is the one we used. Then if you have a semicircle, you again need to use 3 points, because if you only use 2, we don't know which semicircle you're talking about. Are you talking about the left half of this one or the right half? So again, if it's half or more, semicircles, majors, we need 3 points. If it's a minor arc, we only use 2 points to define. Okay, a minor arc, you can use another point if you would like, but it's easier if just to use 2, and it's more consistent if you just use 2. Okay. So now let's fill in the middle here. So let me erase this. So the other piece of information we're going to need to know is that the measure of the central angle is going to equal the measure of the arc. So we're going to have arc measures and arc lengths. So for these notes and for the assignments we're going to do with these notes, we're just looking at arc measure, not arc length. Okay. So the measure of a circle is 360 degrees. The central angles are going to all add up to 360 around the middle here. And the arc measures, these 3 small arcs, these minor arcs, 4 of them, I guess, are going to add up to 360. Okay, a semicircle, half the circle is going to add up to 180. So we know right now this one would be 120, because 180 minus 60 is 120. And same thing for these. Since this is 60, we know this angle is 60. And since this angle is 60 and these two are a linear pair, because we have a straight angle, it's half, it's the diameter. 180 minus 60 is going to give us 120. But we'll see as we go. Okay. So it wants us to give the angle measure or the arc measure, and then we want to write the associated arc or central angle. So we have the measure of FCD. So this is angle FCD right here. Okay, that's FCD. So the measure of angle FCD. So since we know DF, the measure of arc DF is 60 degrees, the angle is also going to be, the central angle is also going to be 60 degrees. Okay. So the measure of angle FCD is 60 degrees. The associated arc is DF. We're using the minor arc, so we're just using the endpoints D and F, drawing the arc line to connect them. Second one's asking for the measure of arc AE, so it's already given for us. It's 45. Okay, and the associated central angle is going to be this one here, which is going to be angle ACE. Angle ACE, this angle right here. And we know the measure of that angle is also going to be 45 degrees, because the central angle, the measure of the central angle is going to equal the measure of the arc. Third one is where we get a little more complicated here. Okay, so this was that angle. The measure of angle ADF. So ADF, arc ADF. So arc ADF, it's a major arc. Okay, it's more than half the circle. Okay, and again, we're going the long way around because we have to include point D, so it's a major arc. Okay. So we want to find the measure of that. So that means we're going to have to find this arc distance, AD, plus DF to get the whole thing. It's arc, just like angle addition and segment addition, we're doing arc addition. Okay, AD plus DF, okay, which is going to be the same as these two central angles added together. So if we can find this arc length or this central angle, we'll be able to solve for the measure of ADF. The way we're going to do that is we're going to use the semicircle. So we know a semicircle is 180 degrees. Okay, so here's our semicircle. Okay, we could also use this line here. Okay, so these two angles have to add up to 180 because this is a straight angle, so we have a linear pair. So those need to add up to 180. So 180 minus 45 is going to give us 135. Let me write that in red. 135. Okay. Which also means that this arc length here, AD, is also going to be 135. Okay. So we can find then the measure of ADF is then going to be 135 plus 60, right? So this is 135. This is 60, right? So 135 plus 60 is going to give us 195. The associated central angle is angle AC. So again, to find this, okay, we had to find these, add these two angles together, or these two arcs. You can think about it either way. We didn't know this one, but we could find it because we knew this was half a circle. Okay, we knew this was the diameter, so it was a straight line. So 180 minus 45 got us 135. Or we can think of it as 180 minus 45 got us 135. Then 135 plus 60 was 195, or again, we can think about it as the angles 135 plus 60 is 195. The central angles added together to 195. The measure of the arcs add together to 195. Okay, the measure of arc AD. So AD now. Purple maybe? Well, okay, let's go back to red actually. So AD was simply this piece right here, which we found to be 135. So it's a minor arc. It's from A to D. Okay, the angle is 135. The measure of the central angle is 135. The measure of the arc is 135. Okay, and the associated central angle with minor arc AD is going to be angle ACD. This angle right here. Okay. The measure of angle ACD is 135. Again, that's because the arc and the central angle are going to be the same. The measure of the arc and the measure of the central angle are going to be the same. Okay, an associated arc we just said was AD. Okay, arc AD. Okay, measure of angle ACF. So there's two ways we can view ACF. Okay, so here's A, here's C, and here F. We can either do this angle here, in which case we'd have to find this one and add these two together, or we can view it as these two, okay, ACF. Okay, let's just view it as those two because we have those numbers. So 135 plus 60 was 195. And again, the associated arc was going to be ADF. Okay. Again, I'm not sure why they put them in the order that they put them, but they did. Just checking to make sure the video is rolling. Okay. The measure of AFD now. So let's look at arc AFD. So here's D and here's A. It's not the short way because it's a major arc because they're giving us another point. So we also have to go through F. So here's AFD. It's going to be in purple here. AFD. So we're going to need to add these three arcs together, or these three angles together. So we're going to have to again use a semicircle. So here is the other semicircle, okay, which means these two arcs add up to 180. These two angles add up to 180. So 180 minus 60 is 120. So that's 120, and the arc is 120. Right, 60 plus 120 is 180. That's half a circle. 60 plus 20 is 180. That's a straight angle, a straight line. Okay, then to find the purple line again, AFD. 45 plus 120 plus 60, 45 plus 120 plus 60. Either way you think about it is fine, but we're going to get 60 plus 120 is 180, and then 180 plus 45 is going to be 225. The associated angle it's going to be angle ACD. And notice again, it's the same as up there, but this was the minor arc, this one was the major arc. So we name the central angle the same, but they're really different angles. You think they would have some sort of way to, and maybe they do, to distinguish between those two. Okay, then the last one, the measure of arc FDE. Well, we have all the central angles. We just have to add together to find the appropriate one. So measure of angle FDE. FDE is going to be this one. Okay, it's the major arc, so it's going around this way. Connecting FDE, we're not doing this way because that's a minor arc. Going the long way around, it's a major arc through point D. So that's going to be 60 plus 135 plus 45. So 145 plus 135 is 180. 180 plus 60 is 240. Okay, and then the angle associated with that is angle FCE. So I think I explained it just as well the second time as I did the first time. Only wasted 21 minutes. So I don't think there's anything else to add. All right, no, I think we're good. So we'll do practice on this on Thursday and Friday. Well, part of Friday.